In this video, we're going to talk about the law of cosines. We're going to go through a quick explanation and then do some examples. So as I stated in the law of sines video, trigonometric functions can also be used to solve triangles that are not right triangles. We use the law of cosines to solve triangles of the form side, 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 or side, angle, side. The law of cosines can be derived by using trigonometric ratios and the distance formula. To save time, I won't derive this equation for you, but notice that when the included angle is 90 degrees, the law of cosines is reduced to the Pythagorean theorem. This is true because the cosine of 90 degrees is 0, and that would make this term go to 0. And as I stated before, that would reduce to the Pythagorean theorem, a squared plus b squared equals c squared. But in this case, we're going to be using angles that are not 90 degrees. So for any triangle ABC, the square of this side is the sum of the squares of the other two sides minus twice the product of those sides and the cosine of the included angle. So again, remember we need to have that angle to be included. All right, let's look at our first example. We have triangle ABC. If A equals 4, C equals 6, and angle B equals 105.2 degrees, solve for the rest of the triangles. So that means we need to find angle A, angle C, and side B. We can't use the law of sines because we don't have enough information, and so using the law of cosines, I get b squared equals a squared plus c squared minus 2 ac cosine of b. So that's going to get me b squared equals 4 squared plus 6 squared minus 2 times 4 times 6 cosine of 105.2 degrees. Putting all of this into my calculator, that's going to give me 64.585. Taking the square root of both sides, I get B is approximately 8.04. All right, so now that I have side B, I have enough information to use the law of sines. So this next step, you can choose to use the law of cosines again, or you can choose to use the law of sines. And I'm going to choose to use the law of sines. So I have the sine of angle B over B equals the sine of angle A over the length of A. So I get the sine of B, which is 105.2, over the length of B, which we just found to be 8.04. The sine of A over A, which is 4. Solving for our angle A, we get the angle A is equal to the sine inverse of 4 times the sine of 105.2 over 8.04. And putting that into my calculator, that gives me A is approximately 28.69 degrees. And now that we know that all of our angles of a triangle have to sum to equal 180 degrees, to find that last angle, I have 180 is going to equal 105.2 plus 28.69 plus my angle C. And solving for C, I get C is approximately 46.11 degrees. All right, looking at this next example, this is an example of solving a triangle with all three sides given. So we're given A equals 15, B equals 11, and C equals 8. So in this situation, I can use any of the three law of cosines equations. So I'm going to start with A squared equals B squared plus C squared minus 2BC cosine of A. So we know that A is 15, so I get 15 squared equals 11 squared plus 8 squared minus 2 times 11 times 8 cosine of A. 15 squared is 225. 11 squared is 121. 8 squared, 64. Minus 2 times 11 times 8 is 176 cosine of A. And so now we're trying to get this cosine of A all by itself. So I'm going to add these two and get 185. And subtracting this over to the other side, I get 40 equals negative 176 cosine of A. Divide by my 176. And I get A equals the cosine inverse of 40 divided by negative 176, which is approximately 103.14 degrees. So again, we can now use the law of cosines, or we can use the law of sines. And to save some room, I'm going to use the law of sines. So we have the sine of angle A, which we just found, 103.14, over the length of A, which is 15, equals the sine of B over the length of B, which is 11. Solving for B, I'm going to get the sine inverse of 11 times the sine, I'm just going to write A to save some room, sine of A over 15. Putting this into my calculator, I get B is approximately 45.57 degrees. All right, so now all that's left is to solve for angle C, and that's going to equal 180 degrees minus angle A, which is 103.14, and then minus angle B, 45.57 degrees. So we get angle C is approximately 31.29 degrees. And again, to find angle C, you could have used the law of cosine or the law of sine. It's really just dependent upon what you're more comfortable using. All right, now we have an application example. It says a skater skates on a fitness trail along the Pacific Ocean from point A to point B. As shown below, the two streets intersect at point C. They also intersect the trail at A and B. In her car, the skater found the lengths of AC and BC to be approximately 0.5 miles and 1.3 miles respectively. From a map, she estimates the included angle at C to be 110 degrees. How far did she skate from point A to point B? So the first thing we need to do is look at our picture over here. So really what we're looking for is this side C over here. The 1.3 miles is our side A, and the 0.5 miles is our side B. All right, so I need to know what C is. So we have the equation C squared equals a squared plus b squared minus 2ac cosine of my angle C. So we get c squared equals our a, which is 1.3 squared, plus our b, which is 0.5 squared, minus 2 times 1.3 times 0.5 cosine of C, 110 degrees. And that gets me c squared equals 1.69 plus 0.25 minus a negative 0.445. That's going to turn into a plus. And I get c squared equals 2.385. So c is approximately 1.54 miles. So that means when our skater skates from point A all the way to point B, she has skated approximately 1.54 miles. So that's really all you need to know about the law of cosines. Keep in mind all three equations and that you always have to know at least two sides in order to use the law of cosines. And once you have found that other side, you can then use the law of sines to continue to solve for the triangle. Remember, solving a triangle means to find all three angles and the length of all three sides.